What's happening, dogs? Mr. Allen here. So I just got done calculating the height of the Norge ski jump, and there was a ton of math involved that we quickly went through in that video. So I'm gonna do a full-length one here, a full mathematically awesome explanation of what the heck just went down. First thing I want to do here is redraw that diagram. So I set my tape measure up at a length of 34 feet, and I took 2 angles of observation. My first angle from farther away from the jump was 55 degrees. And then I walked 34 feet and looked again, and I had an angle of elevation of 64 degrees. Now I can still find my height here, which I'm going to label as x, but I'm also going to need to introduce a second variable here because I don't have a completed right triangle right now. So if I've got 2 variables I need to solve for, I'm going to need 2 separate equations. First one I'm going to do is this smaller triangle right here. So I'll have tangent of 64 is equal to my opposite over my adjacent. Then for my second one, I'm going to take this angle 55. I have my opposite side of x, and my adjacent side here is 34 plus y. Now what you may notice about these 2 equations is that they both have x in the numerator, and I can use that. I'm going to multiply by the denominator on both sides for both equations, getting them both equal to x. Since both of these equations are now equal to x, I can set my right-hand sides equal to each other, which only contain y, and then I can solve for a single variable. I've got a y here, and I've got a y here. If we get both y's on the same side, I can factor the y out. Check this out. Since both these terms contain a y, I can factor that y out since it's a GCF. Now, why is it significant that I have only tangents left over with numbers? This right here is just a number if you plug it in your calculator, a nasty decimal. Same with this guy over here. So if I have a variable times a number, even if it's an ugly decimal, equals a number, I can just divide by that number to get y by itself. We're going to do just that. Now it's time to bust out that TI. I'm going to hit alpha y equals to set up a fraction here. I'm going to type in 34 times the tangent of 55, arrow down to my denominator. I'm going to have tangent of 64 minus tangent of 55. And I get 78.046 for my y value. Now, that's not my height of the jump. That's the distance I was away from being directly underneath the ski jump at my second angle of observation. But it's still a useful value. Now, what you can do is you can store this value in your calculator so that you can use it any other time you want by hitting store. And I'm going to choose alpha y so that it matches my diagram here and hit enter. Now, when I look forward to, say, solving for x here, I look up at this blue equation right here, and I see x equals y times the tangent of 64. So I could have either just multiplied that y value that I had in my calculator by the tangent of 64, or I can also use the y value, as you saw me do in the video, multiply that by the tangent of 64, and get the same exact result. Since I ended up using that y value right after I solved for it, I didn't necessarily have to store it in the calculator. But you never know when it might come up again, and now it's stored as y. If I wanted to, I could have just taken that first initial answer of 78.046, hit times, tangent, 64 degrees, hit enter, and you see we get the same exact answer of 160 feet for the height of that ski jump, which was dead accurate. That was pretty dang dope, man. That was super dope. That was a fun day. I hope this makes a little more sense to you guys as far as the math that was involved. You could also do this with non-right triangle trig, but not everybody knows that non-right triangle trig stuff with law of sines and then right triangles. So 2 tangent equations get the job done here. Super awesome, super fun, and I hope you guys enjoyed both of these super dope videos. I'll see you guys later.